So we're going to move on to 6.2. 6.2 is just the beginnings of a much larger world, and it's going to come back to haunt us a little bit later on in the course. So the thing that we're interested in is something called a binomial experiment. A binomial experiment is one in which the experiment is performed a fixed number of times. Each repetition of the experiment is called a trial. The trials are independent of each other. This means the outcome of one trial will not affect the outcome of other trials. For each trial, there are two mutually exclusive, i.e. disjoint outcomes, and we're going to call them success or failure. And the probability of success is the same for every trial of the experiment. Now, this is a really important idea because this is how polls and surveys work, hypothetically speaking. So, for example, let me just give it to you. If I was going to do a Gallup poll of Obama's approval rating, they always want to know that about presidents, rating of 1,000 people. Let me just give you that example. Okay, if that's the case, then every time I call a person, right, it's a trial, right? I'm going to do N trials, oopsie, stop capitalizing, trials, i.e. phone calls. The calls are independent, right? We talked about that in chapter 5. I mean, when you call somebody, it's not going to have any bearing. What they say about Obama is not going to bear on the next person, as long as the people aren't related, and that's most likely the case. Okay. For each trial, there are two mutually exclusive outcomes. Approve Obama. I should capitalize that. Do not approve of Obama. And technically, it's like the job he's doing in office or whatever, but you get the general gist. They say, do you approve of the job that President Obama is doing? That kind of thing. All right, now what about 4? The probability of success is the same for every time. So suppose 42% of people in the U.S. approve of Obama, technically the job in office, then you expect each person to have a 42% chance of approving of him when you call, right? So every time it's exactly the same for every person. Interesting, huh? So this binomial thing is laying the foundations for how we're going to deal with surveys and polls. And that's kind of a big deal in statistics. I mean, we need to know how to work with surveys, and we need to know how the foundation underneath the structure. So we need to know how polling and surveying will work so that we can answer questions about it. All right, so let's talk about the notation for a second. So Amber has a weighted 6-sided die that rolls a 6 90% of the time. She rolls the die 4 times. Explain why this is binomial. Find NP and Q. Okay, so let's start with, there are N equals 4 trials, right? The trials, i.e. rolls of the die, are independent. You roll a 6 one time doesn't mean you're going to roll a 6 on the next time. Even though the die is loaded, it doesn't mean that one roll affects the other. Okay? Now, what's P? P is the probability of success. Oh, for two mutually exclusive outcomes. We have success, which would be roll 6. Failure equals do not roll a 6. So all the other sides. So 6 and then not 6. Right? Success and failure. And then P, very important to us, P is 0.90 for this die. And Q, which is the probability of failure, which is 1 minus P, is equal to 0.10. Right? So a lot of times I'll say Q, and when I do that, I really mean 1 minus P, because they're complements of each other, because you either succeed or you fail. And it's the same every time. All right, there we go for what binomial means. Now we'll do some problems with it next time.